And hello, everyone, and welcome back. Hope everyone had a pleasant break for the start of the year and got to relax and everything like that. Uh, yeah, I'm basically going to be diving right into this, which is continuing on with the development of the scanner slash Lexer for the Laurel programming language. For those unfamiliar with the project, the idea of Laurel, in fact, maybe I'll pull up some sample code. And the idea of Laurel is that it will be a scripting language in the similar vein of POSIX compliant shell scripting, such as Bash and things like that, with a focus on hopefully keeping the what might be considered the elegance, or at the very least the efficiency and ergonomics of the likes of POSIX shell scripting. So ideally, minimal amount of plumbing or quotation marks and things like that in order to encapsulate processes or define processes, but to add in more of the mainstays of a lot of programming language features that we're used to. So, one typical example of this would be more regular structures for the likes of while loops and if statements and things like that. So, looking at this sample code, maybe one of the first things to observe is that a lot of this probably looks quite familiar if you're familiar with C-style programming languages such as C, Java, JavaScript, Rust, all these kind of things. And that's intentional. Really, the main part of this that isn't like your typical language so much is the part where we're actually calling processes or starting processes from programs. And let me see if I can find one down here. So here's an example, probably not the best one, where we're calling the SH program, passing it some parameters that will change its kind of these would be what I would consider subcommands. So we chain together subcommands. Functionally, they're the same as just passing more positional arguments, but we then pass in the positional arguments as if they were function parameters. And the idea really is to have, and here's another example of running a program. So this is running the uname program with these parameters and capturing its standard output. Running the ID program, and I'm not sure the output is captured there. Instead, it just checks, did it run successfully, things like that. And the idea behind this work really, and here's an example of, so these aren't actually running the commands at the time, they're return commands by building up a program with its subcommands. And the idea, sorry, one last example. So this, just because it's a little more comprehensive, running this sh command, maybe it's not as comprehensive, but it maybe demonstrates how in Bash and POSIX compliant shell, we sometimes have issues with string splitting and concatenating things together and constructing this kind of sub program almost to pass to as an argument to another program. And this is achieved in this language a bit more naturally, I would say, by using regular string splitting and combination operators. And so the idea really is to, like I say, try and keep some of the ergonomics. So one thing that might be noted is that, again, it varies depending on what kind of characters are involved, but for some of these parameters, for example, with sh and sudo, maybe this script isn't the best example, but we can omit the quotation marks and things and get a little bit more of that bash and shell feel. by omitting those quotation marks. In fact, in this language in general, any string that isn't delimited by quotation marks is assumed to be a string by default, rather than a variable, whereas a variable has to be prefixed with a dollar symbol. Oh, hey, Lord MZTE, good to see you again. Hope you had a pleasant New Year. So that's kind of the idea of the language anyway. Just a very brief run through. Yeah, again, main goals are to ideally keep the ergonomics and utility of shell scripts, like the fact that they are quite useful and quick to write, especially for plugging different programs together in kind of a pipeline and things like that. But then trying to remove what might be considered the more clunky aspects, which I would consider to be things like its semantics around string splitting, kind of string expansion and string splitting and things like that, and also even just the look and feel of the operators and control flow of the language. Even since beginning writing this, I've come up with so many ideas on the approach that I'm taking now, and I have invalidated some of my own ideas and come up with new ones. But where the project is now, really, and again, I suppose is a good point to catch up, is I have been developing this in two phases. Oh, thanks very much, Lord MZD. Sorry for the delay. Thanks very much for your comment. But to kind of catch up with the roadmap of the project, I suppose, where it is now, I suppose you could consider it phase 2 of the development. So if we consider phase 1, and I can open the repository for this actually, so I have it on GitHub. I have it all currently, and this is one of the things that kind of changed along the way as well. I was developing it under this kind of heading called NORPL, for not a real programming language. The idea was the first phase was that I developed this kind of core, which wouldn't actually contain any of the novel aspects of the language itself. Instead, it would be kind of just a general basis for, if you were going to write a C-style programming language, you could nearly start from this base, and it would give you kind of most of the general stuff out of the box. And there were two reasons for doing that. Number one is that it's I think it would be a nice utility, and it's available under work in progress dev, so it is unfortunately still a work in progress repository. It does. I've been writing it in the stream, and so I've actually been focusing more on getting features done rather than refactoring and having comprehensive tests, which I would consider essentially if I were to say publish this formally. But the idea for this phase 1 is that I would have this kind of solid core that, first of all, I could, if I had ideas for other languages that were similar, I could start off from that kind of basis and add and remove what I needed to play around with different ideas, basically. But also for this language specifically, the idea was that I wanted to start off again with this core set of features and consider, kind of use it as a research tool to say, okay, if I add this kind of general rule, or if I change the language in this very broad way, how would that affect the rest of the language, or is that even possible? So one of these one of those aspects that came up fairly early was the idea of having identifiers be strings by default. So if you type an identifier in the language, the same way in Bash, with Bash, everything more or less is a string. Every identifier is a string, even integers and things like that, I believe, and they only get coerced into, and they don't even really get coerced. They actually, if you use programs like Test and things like that, Test courses them itself, but under the hood or within the realms of Bash, I believe they're still just all considered strings. Whereas this language has a mixture um, for structural purposes, and just considering how does that balance out? Is that possible? Does if I do apply this as a broad change in the context of an existing language, does it make things break? And I was surprised to see how many of my ideas actually stood the test of, still working in the context of a working language. Um, oh, sorry, I've been losing track of the comments. Yes, actually, so this was so in terms of the Vim syntax, this was something that I took, I believe, a session for before the break, and really it mostly highlights kind of control flow and strings and things like that. And I think it has support for comments as well. So if I do a comment here, yeah, so it has kind of the basics. It was, it wasn't, a strictly necessary change, but I definitely feel it has improved my um, kind of the visuals a lot, and definitely makes it more comprehensible for me. Um, in turn, oh, yeah, hate when keyboard keys get stuck. But in terms of Ruby, Ruby does what exactly? Sorry, I missed the part where you made the comment. But yeah, so that that was the approach for phase one, and now I am kind of in the midst of phase two, where I am kind of applying more of these novel features. Treat everything as strings. Oh, that's interesting. I'm not actually sure, but I do believe that Ruby, from my understanding, Ruby still has um, typing, and I would probably say, again, I actually have very little experience with Ruby in particular, but my understanding is that in Ruby, everything would probably be closer to an object than a string. I believe that it uses message passing a lot, and then, excuse me, um, I think my understanding is that it's actually fairly object orientated, so that things are objects. But then that's it probably has been over a decade since I've actually even programmed in Ruby, so I could be easily forgetting it. Um, so the other aspect of, yeah, this phase then, and I've actually I suppose the novel changes really that I've completed for the most part um, are almost all the ones I want to. So I have a couple of concepts of prototypes, kind of JavaScript style prototypes in here. So that there's a distinct object space for the keys defined, or for the values defined on a user defined object versus um, the functions defined in the language um, based on the type. But that was probably more to do with the core. The main novel things really are the process, um, the running of processes, the building of process, kind of pre-evaluated processes being built up as sequences of arguments and strings, and then evaluated at the end. Um, Maybe some error handling and things like that. And for the most part, it's actually mostly uh, completed. I would say there are a lot of things to optimize, and there are a lot of areas potentially to fix, which I'll have to look at. Um, but that's kind of the current state. It is actually close to initially feature complete anyway. One area that I am, and what I'm in the midst of now is finally, and this has been a long time coming, actually looking at the Lexer for the language. And um, there are a couple of reasons for this. So I'm using the LALRPOP framework with Rust to build this project, and basically for months I've been using the auto-generated Lexer that comes shipped with LALRPOP, and that's been mostly fine throughout the project. But there have been a couple of rough edges. One of the uh, biggest ones for me from a debugging perspective is that when it gave errors, especially token based errors, it always gave it as an offset into a file. So it would say, character 200, is an invalid character in this context. And to me, when I'm looking at the file in terms of lines, not having a line number is very difficult to deduce. I often had to join all the lines onto one line and figure it out based on that. Another big thing I believe was looking at proper string handling semantics. So LALRPOP does give you a certain amount of freedom with defining maybe more custom Lexer rules using regex and things like that. But for me, first of all, I would be far from a good user of regex. I do find it kind of tricky. I actually use it a lot. I use it in things. I use it in Vim and sed and grep and all these kind of cases. But at the same time, it's very much an iterative process for me, and I would actually have a lot more confidence in a string parsing rule that I write kind of more by hand to one that I would write using a regex. I would have a lot more faith in other people's ability to write string parsing using regex than I would my own. So, but then defining the Lexer by hand then gives the opportunity to define that kind of flexibility that I'm looking for. And there are a couple of other benefits that would be kind of essential that I'll need at some point as well. One of the things I'll be looking at in time, again, to maybe emulate uh, Bash, and to also borrow an idea from Go in particular, even though a lot of languages have it, but the idea to remove semicolons at the end, and again, similar to JavaScript. And the way I would do that isn't like these semicolons would still be there in theory, but they'd actually be inserted by the Lexer once it encounters certain scenarios. So it's not that the language wouldn't have a strict definition for what terminates a statement. It's that it'll be, a little more invisible, shall we say? Because I do think the Go approach is quite a nice one. I've actually gotten burned, I think, once or twice with the JavaScript approach, whereas the Go one I've had less trouble with. But maybe that's actually to do with the Go types rather than the Go semantics around semicolons. But that's just my own experience. So with that all said, what I'm in the middle of now is just finishing off, hopefully, some finishing touches on the Lexer. Now I am left in somewhat of a tricky situation, because where I had left this last time, there are a few bit. I've left a little to-do list for myself of things that I've yet to do for this, and I'll be trying to knock these out and uh, get that all working nicely and what have you. But the big difficulty is, as I was developing this, encountering more and more subtle issues that I suppose, couldn't be caught by the type checker and things like that. I suppose I had a lot of faith that the type checker, as I was building this, that if I kind of followed the rules of LALRPOP and Rust, that at the end of it, it would be kind of a plug and play replacement for the built-in Lexer. And what I've come to realize is, maybe it was more obvious than I should have thought, but it's there are a lot of subtle errors that can come as a result of this work, and ones that could cause my kind of programs to fail in surprising ways and result in more debugging work for myself down the line. So I am brought to this kind of interesting situation where, do I merge the changes once I finish them and take the risk, or do I wait until I have more comprehensive test coverage before I do that? And I'm still not sure what the right approach is here, because again, I want to keep progressing with the stream and doing interesting stuff, but at the same time, this is something, it's at the point where this really would need some good test coverage in order to commit it fairly comfortably and confidently. So, but that's not necessarily an issue for this stream. There's a few more bits that I can add in before I decide to merge this, and I will be putting it on a separate branch. So there'll be basically that's an issue I can deal with at another time. So that was a big load of talking, big catch up for the new year. So yeah, next step is to just dive right in, really. So the first thing that I'll be looking at today that I couldn't bring myself to resolve at the end of last session was resolving a precedence issue in the Lexer. So so if we take a look at this next function, as in literally called next, it's built up as kind of a sequence of checks. So it checks if, so what we're doing in the Lexer, for those less familiar with how the Lexer works, is we're essentially at a certain point in our source file and we're taking a look at, I'd love to use this. I've been looking for a good scripting language for a while. Oh, thanks very much. I'd love for you to try it out when it's in a more robust format. But thanks very much for your comment. So that would be the intention as well, of course, that people would try it out and see if it suits their needs. Like, I'm very much designing it to scratch my own itch. So, I wouldn't be too surprised if hopefully other people got some utility out of it as well. But thanks very much for your comment. So continuing on here, what we're doing is basically splitting a string or our source file into a sequence of tokens in an iterator-based fashion. And so this is kind of our iterator function, which will basically start at a certain point in the file that's defined. We're keeping track of that in where we are in the file internally, and then we're responsible for going to the parsing the next sequence of characters as we see fit and returning a corresponding token. And the way we do that is we basically just use a sequence of kind of look aheads. Most of the decision is actually going to be made based on the first character we see. So, for example, first thing we do, of course, well, in fact, I might as well just recap the operation so far. We skip any white space and comments that we're currently in front of. So we're now, once we skip all those, we're now at what's probably some alphanumeric character or a symbol, or possibly the end of the file. So the first thing we want to do is just double check, are we at the end of the file? And if so, then we actually say we return none to indicate that there are no more tokens in the stream. Otherwise, we grab a reference to the next character. Next thing we do, we check, is this a symbol? If it is, then we can just return it as is, in addition to some location information, which I need to simplify later, hopefully, because this kind of a pattern is repeated throughout this function. And in fact, now that I look at it, I'll get back to this in a second, but it looks like I'm actually handling this issue in a fairly kludgy way, but handling it all the same. So if it's not a symbol, then we check, is it an alphanumeric character? Is it an alphabetic character? If it is, and this is kind of one of the reasons why I believe a lot of languages will allow you to, so you can, at the start of an identifier, you can only use an alphabetic character, but then you can use a sequence of, alphabet, numbers, or underscores in the rest of the identifier. And I believe this makes the actual tokenizing a lot easier, because you can see at a glance, is this a number, or is this an alphabetic, or is this an identifier? So we say if it's alphabetic, then we keep parsing alphanumeric characters until we reach something that isn't part of a valid identifier. Then we check, is it one of the reserved keywords, and we turn it into a keyword token. But if it's not, then we turn it into a string token. Then if it's a digit, then we do a similar process, keep reading until we get something that isn't a number character, and then we return an integer corresponding to it. Now in this language, because we have, in fact, that would be what would happen. Those two steps would be what would happen in a regular language. In this language, like I mentioned earlier, an unquoted string or a general identifier actually gets converted to a string literal if it's matched. And all identifiers actually start with dollar symbols at the moment. I say at the moment, this might be something that's going to change eventually. But this is what defines an identifier. Then if we match a quotation character, then we don't have any escaping mechanism here yet, but we basically keep matching until we reach the end of the string, and then we return a string token. And if it doesn't match any of these, then we get into the realms where we're looking for character symbolic tokens that consist of more than one symbol. So we're things like not equals, double ampersand, and all these kind of things. So sorry, just going back to the comments now. Couldn't you use the question mark operator instead of return none? So when you say, oh, sorry, yes. So in the likes of, let's see, double checking here. Yeah, that's a good point, actually, that this could probably be replaced with, what would we say? This would probably be, if let's see is equal to self peak char question mark. Yeah, absolutely. Yeah, it's been a while since I've looked at this stuff, so I'm actually quite slow with it. So if I do that, yeah, that would probably give me the same result, wouldn't it? And enabling line numbers, yeah, that's a good point, actually. So I believe in yeah, so let me know if that helps. So I think that's the, and do I have to do it in each window? I probably do. Let me know if that helps. Great stuff. So yeah, this function already is greatly in need of refactoring. So last session was probably more the implementation phase, and there'll be a, how should I put it? Yeah, I'll need to do some refactoring and splitting this out into maybe more appropriately named other methods as I go along before I do a full commit. So probably don't need the oh, how do I disable that? Oh no, it's not let, it's set no number maybe. There we go. Probably don't need it over there. So I believe this is handled albeit in a somewhat kind of clunky fashion because it's duplicated in two sections of this function. And I also have some debug errors that I need to remove. So maybe in order to make the first commit of this new Lexer branch, and in fact I better put it into its own branch. I believe I'm currently on work in progress Laurel at the moment. So what I'll do is I'll check out, let's see what I'll call it. Refactor, or I'll call it custom Lexer. So, and I'll just double check the files that I'm working on at the moment. So I've modified the Laurel file that I'm working on so far. So I seem to have commented out something. Oh, in fact, I can probably think I just have a certain section double commented, so I can remove that because comments now work in this language. And now that the scan, actually, that was another thing that I added support for, was proper support for comments in the language, which I didn't have for a long time, but it was actually due to my own silliness. I had to actually, when I was during part of the process for actually reading in the file, I actually removed new lines. So it meant that comments actually continued on to the end of the file rather than to the end of the line. So that was my own doing. So let's see. So there's just a single new line difference in that file. So if I change that, I can actually get that down to 2 files of difference. Yeah, so that's that. And yeah, so then the only files that will change are the addition of the new Lexer, updating the parser to use the new Lexer, and then updating the main file to pass the new Lexer to the new parser, or to the parser that's been updated to use the new Lexer. I've been wanting to write a parser with the nom crate, but never gotten around to it. Actually, yes, there have been a couple, and this has been something that's mentioned a couple of times, just the different approaches or different Lexers that have been, are available. This is very much the type, the LALRPOP parser generator is the one that kind of made most sense to me in terms of kind of, I suppose I'm used to writing them in this kind of a fashion, but I believe then some others, such as I think there might be some ones that work maybe better with peg grammars, but then I have less familiarity with those. I actually decided to omit multi-line comments from the language based on mostly based on a convention in Go, which even though Go does have support for multi-line comments, they're generally not used in as part of the source code. And as I use more Go, it's actually something I quite like, mainly because I find it's easy enough to, in my use anyway, say with the likes of Vim, it's very easy to highlight a section of code and then just kind of comment it out using a character insertion for that whole block. And the benefit of that is I find then when I use multi-line comments, the nesting of them tends to be a bit tricky in the sense of if you're deciding to debug something and you want to comment out a big chunk of the code very easily, um, I I actually tend to find that multi-line comments get in the way. It's probably it's a very subjective reason, and it might be something that I revise later, but I just yeah decided to leave out multi-line comments at the moment. But it's funnily enough that's something that's quite common in scripting languages, I suppose, like Python, Ruby, and Bash and the likes, to only have support for single line comments, which yeah, for better or worse, it's actually something that I've kind of gotten used to. So, but maybe that's something that could change in time. So, continuing on from here, yeah, it's probably at the point. So I believe this is resolved now. So what I might do is I'll just indent that to say that it's done. And I'll take a look at resolving some of these no commit comments and maybe breaking this massive next function into more manageable pieces. So let's see. Now the issue here is that each of these sections is kind of, I suppose, has a mix of responsibilities. So it's doing a couple of things, which is never good for breaking something up into functions, because what it's doing is generally both matching the character, which is fine, but it's also capturing the start point and end point of the token, and that's kind of a mix of responsibilities. So what I'll probably do is just go ahead and start refactoring some of these and see how far I get. So maybe the first one to look at, possibly one of the easier ones, is to look at matching an integer because matching a number, because the semantics are generally fairly straightforward. Now this language actually doesn't have support for floats, kind of for a similar reason to maybe the kind of original Python and also Bash. Python has evolved to be kind of a very general purpose programming language, which is, I think, why it eventually did add in the support for floating point numbers. But for the likes of Bash and this language, really, I suppose they could be considered to be mostly used for plumbing and not really for kind of heavy algorithmic use and number crunching and things. So the idea is, if you are going to be using floating point numbers, it's very highly recommended to do it in a language that's kind of more appropriate for that. Oh yeah, good question on the imports there. At the moment, and this is something I've somewhat left off for the moment to be fleshed out more fully later, but just because you ask, I'll take a quick detour. It's defined in main at the moment. At the moment, importing is purely runtime based or purely in memory, so it's not based on files at the moment. So for example, if I take a look at what is the standard library at the moment, these are all defined. These are packages that are currently defined at runtime because they're mostly reflection based. For example, so if I open up the import for the language here, we import pros, and from that we access env, and we also access args, and so those are defined at runtime and made accessible to the language via the import system. And it's a mechanism to use the or to access the environment, or the, I suppose what you might consider the operating system level parameters to the program. But as so basically the actual file-based import mechanism doesn't exist just yet. And the main reason for that is I'm still working out, well, it's I have a lot of thoughts on it already, but still trying to figure out the exact semantics. I'm thinking with this language, um, hopefully trying to learn lessons from my use of bash scripts and from my use of the likes of Python and things, that a lot of this will hopefully be kind of rel the importing of files will be relative based, if that makes sense. So there might be a certain file that you can add on the into a project, for example, because I tend to like structuring my script space relative to a project root. And so there might be some file that defines the project root, and then all your scripts and imports will be relative to that root. But then there might be some environment variables saying that they're, where some system scripts live for importing it. And but again, because of that kind of lack of clarity around that, it's something that I still need to yeah, exactly. So there might be something like, if I go into here, there might be something like import, your standard, um, I could have a scripts directory, and I might have a certain function that defines env-or, and I might call it env-util. Don't love the util name, but I think it captures it well here. And then instead of env-or in this script, I could be using, env-util.or maybe. But the important part here is how we get to this file where it's going to be defined relative. Actually, that's a very, very interesting and important point, Lord and MZT, and something I was actually discussing and passing with someone else recently. The prefixes are ones that I'll have to be very careful about. It'll it would probably be if I type it in here, it'll probably assume this by default. So this dot slash notation will be implied, but there definitely won't be support for the likes of double dot, because then you can there are potential security complications as a result of that. But and similarly with the likes of this, if you have someone running, if you manage to get someone to run a script on their system, again, if it's probably a mix, because if you're getting someone to run a script on their system anyway, you've got a lot of control. But some of these kind of characters can be abused a bit. So I'd be defining quite. It is something that that's one of the reasons why I need to give a lot of thought into exactly how this kind of stuff will be structured. But there might be some character like that, like I've encountered in some JavaScript projects, which allows you to access files relative to the project root, and that's where some root file called, maybe root.lorl, that defines your project, or the same way that we've got, package JSON in JavaScript files to define the project root. There might be some similar mechanism here, and then this at symbol will be defined relative to that. But yeah, that's a very good point. The dot dot in this scenario really wouldn't give any extra power, because yeah, the whole utility is that it's able to traverse the file system easily. But like there would definitely need to be some mechanism for for accessing files in a parent directory, but whether I'll be doing that using relative, for example, relative paths in the import statement, or if it'll be done via kind of relative statements relative to the project root. Yeah, and that's an interesting one as well, is the idea of global libraries, and because it's kind of it's a tricky one, because then leads into I suppose, a number of considerations, because for example, I suppose it leads to a lot of kind of platform dependent design considerations. So where are these there probably are a lot of standards, but even just deciding where are the global scripts going to live, and how are they going to be kind of versioned appropriately and things like that. There's going to be, I suppose, yeah, imports in particular. There's been a reason I've been kind of putting it off for a while. Um, Yeah, that's a good point too. I've also been playing the idea of using environment variables, and that's probably the approach that I've been most I've been most interested in for defining the, for example, maybe global properties of the language. So again, borrowing from another language, similar to how Go kind of did it originally. So Go had all these environment variables to define, say, the project root and things like that. But it kind of suffered from the fact that it defined so much of its configuration in environment variables. Then the idea I'm kind of tempted by at the moment is that there would be one environment variable to define basically a configuration file for the language, so that if it's provided, that config file is referenced then to get more details of the installation on that system, and that could hopefully be used to maybe work around what I see as some of the potential pitfalls of having this set up on different platforms and things like that. But again, these are all the ideas kind of floating around in my head, and they're still a bit muddled at present. So there's a lot to be decided. Yeah, I agree with Go, and it's suffered from that for a long time, and there's still a bit of legacy around it as well. I think they've done a good job for with kind of migrating away from that kind of everything has to be in a single workspace on your computer kind of an idea. But but yeah, it's again, there's a lot to be learned there, and to hopefully avoid in terms of yeah, making the same mistakes. Yeah, exactly. The Go path fiasco, and which they eventually moved on from. But yeah, it's something that can be definitely learned from. So yeah, I'll hop back in, but thanks very much for the interest and the discussion. So so what I'll jump into here now, um, the module system. Yeah, I'm not a big fan of the. Well, I think in theory it's fine. It works kind of as a good base. Like it I suppose doesn't have all the kind of fancy stuff around, say, semantic versioning and things that other languages have, but I'm not sure that's something that I entirely miss, because I prefer to pin versions anyway. So um, it's not a big deal breaker in my opinion, but I've definitely run into a lot of issues with, in particular, the checksum database and things like that have made my experience with it less than ideal. But yeah, it's one of those things. I think Cargo is probably one of the best experiences I've had. Well, actually, it's a controversial opinion, but one of kind of best experiences I've had with package management, I think it was actually Maven, but that could have also been because it was at a time where dealing with like jar files and jar file repositories was so broken that Maven was just this breath of fresh air that just solved so many problems and was so lightweight at the time. So um, maybe it's kind of more rose-tinted glasses than anything, but I think as a second kind of the best experience I've had since then, I think, has been Cargo. But again, I have run into issues with Cargo as well, and even in terms of um, I suppose some what seemed like forced updates of I think it's for some kind of packages. I think they force you to update the uh, the version after a certain amount of time, and I have run into breaks because of that. But on the whole, Cargo has been very nice. Um, bit shift operators, actually, yeah, good catch there. That's actually because the bit shift operators. Oh wait, sorry, bit shift operator. Yeah, sorry, apologies, but yeah, there's no bit manipulation in the language at the moment. Definitely something I would consider best left to the likes of C and the likes. So anyway, so where was I? We have, let's see. Yes, so is ASCII digits. So what I'll do here is I'll define next int, and that will parse from the, it'll essentially be doing this this block of code. And oh, good question. And this isn't something that I'm kind of totally happy with it. In fact, I'll open it up in the source code here and jump to it. So here, so this is actually an indexing operation, kind of complementing the regular indexing operation. And the idea, again, still playing around with ideas here, but this is as can be seen here, actually, this is a safe index access, and this is an unsafe index access. And with the idea being that if you access an index in this way and the item isn't there, then the program will panic essentially. Whereas if you access it using this mechanism, and this is just the kind of current syntax for this, I'm not sure exactly I'll settle on long term with this. But the idea here is that if you access it using this mechanism, it falls back to a more Go-based approach. So if I take a look here, that that seems to have replaced. I think you meant to write a token, yeah. But here's an example of this original token in use. So it converts it to a value, what are they called? Sentinel value pair, so that you can easily see, did this access work or did it not? There's potentially an easier or maybe a nicer way of incorporating that into the language, but just still playing with ideas at the moment. So it's the the sad face token. So that's actually the character for starting a process. So, and again, this is all stuff I'm kind of feeling out as I go along. But one of the things I kind of noted early on is that I actually had it so that, in fact, if I jump down to maybe a more complicated, no, there aren't really many more complicated examples, it doesn't look like. So yeah, I'll go back to here. So it's essentially starting a process. And I originally had this kind of a syntax where it looked more like uh, running a process looked ideally. It looks sad to start a process. Yeah, absolutely. So the idea here was that it would look starting a process would look very like starting a method. The one of the examples I often give is accessing, say, doing an ls of, for example, Docker volumes. So if I did Docker volumes ls, I could run it like this, and maybe I could pass a v parameter. And so these are all the subcommands of this. These are converted to strings and appended as arguments to the Docker process or to the Docker program and then run. The difficulty I see with that, and not that I see this as being much nicer looking, but the difficulty with this is that it's easy to accidentally do the wrong thing, I think. One nice thing about having different operators for different operations, because this is a different operation, it looks like, calling a method, but it performs like running a process. Um, and while it looks nice, at least the programmer in me thinks that looks very cool, and it's really nice that it has this kind of, it looks like running a method. The difficulty is readability, really. At a glance, it's not obvious what this code is doing. Is this, Docker, if I had this and it contained the string Docker, this would look like it's calling a method, but then it's actually calling a process. And that to me isn't kind of an ideal trade-off. I do like code to be kind of obvious at a glance. So while it does, it does nearly pain me to change the structure to this, at the moment, I think this is at least it's more obvious what it's doing. So it's a better trade-off in the short term anyway, until I come up with a syntax that makes more sense. Are ifs not expressions in this language? So ifs are, oh sorry, no, they're statements at the moment. I've left out the kind of the Rust approach of having the likes of if commands be expressions. Yeah, sorry. So so let's see. I'll do all of that. Yeah. So let's see. There we go. And so yeah, that's the explanation of those operators. Anyway, again, thanks very much for the questions and the interest. So good question. And this is quite an interesting one and an important one. So this is actually how so the arrow operator is how prototypes are accessed in the language. So this language, I say prototypes, but it's not kind of, to be honest, I don't know much about the theory of prototypes in the likes of Selfa and JavaScript. But one of the nice things about the likes of JavaScript is the fact that objects themselves function like maps, in that they're naturally reflective. So you can access a field of an object programmatically very easily. And I think that's really nice, especially for a small scripting language. It can let you do a lot with very little. Like it gives you meta programming out of the box without having to do, lots of, say, code generation and things like that, or macros or things. The big downside that I assume a lot of others encountered with JavaScript, potentially even start when they're starting out, is the fact that um, uh, that within objects, the kind of space within which you define the fields of an object is the same as the space in which the prototype fields are defined. So for example, what am I doing here? I want to go up. So for example, in JavaScript, if I do something like, let's see, if I have a variable, let x is equal to that, I believe there are a small number of prototype level functions defined on x, and there can be kind of overlap on them, and that because of that you have to get into this territory of has own property and things to find out, is this actually a field that I've defined, or is it something that the language has defined, or what have you. And I think a lot of modern JavaScript has kind of smoothed over a lot of these rough edges, but the approach that I've taken from the start is that the built-in functions related to types, are just part of a completely separate space. So you can still, they're still first class functions, and you can assign them to things and you can pass them around as arguments, but the way they're accessed is fundamentally different. And I think that's quite important for simplicity. I don't see a massive benefit to, it's somewhat unfortunate that it complicates the language, that there has to be another, a separate operator for accessing type-based functions. But again, the explicitness and the clarity in terms of saying, okay, I'm calling a function that I've specific, for example, if I had an object and I decided, so I believe objects in this language, in fact, do I have any methods, built-in methods defined on the language? Sorry, I just have to remind myself to double check. So I've defined functions on lists and strings so far, so I don't have object prototypes. But if we can imagine that there is this definition of count, or num entries or num keys, or even just keys, defined on objects in the language, then I'm free to access this function and know that I'm calling the object-based function or method. Sorry, I'm getting my terminology all wrong. And then, but even if I define keys here, and I say keys is actually this thing, and I'm going to make it very confusing and make it an array as well, and I'm going to make it an array of strings, even though I'm defining this field that has the same name, because it occupies a different space, or in fact, this could be a function as well, so it would be fn return. So even though, or because it occupies a different space, I would say there's no ambiguity between the two of these. Like in this case, I know that I'm accessing one type of function, and in this I'm accessing the field defined on the custom object, if you will. Sorry, big long-winded explanation of that, but that's essentially where that comes from. So again, thanks very much for the question. So hope the answer wasn't too boring. So yeah, so continuing on then, the function or the method that I'm working on here is, let's see, what will be my types for it. So it'll be defined on self as well. In this case, I don't think I'll be returning a self item. Well, we'll see. So in general, I like to, take proper parameters and then return, you know, proper values that can then be kind of reconstructed in the parent, rather than kind of using using class variables, or these would be instance variables, to kind of bypass the parameter system. But because there are so many here, I'm just wondering, does that approach make sense? So let's just take a look at oh, no problem at all. Thanks very much for all the questions, and see you when you get back. So what I'm wanting to do here is we start off at this point. We know that because we're in the context here, that we've asserted that the next character is going to be an ASCII digit, and so we can assume that at this point. And so we say, okay, we're at the start of the token here, so we kind of earmark that information. Then we parse, or we aggregate the rest of the token, build it up, and then once we get to the end, we again earmark that. Then we do the actual parsing of that item, and finally we return the details. So maybe because we have all that information around us, maybe this makes sense. I feel like there's hopefully some way of abstracting this kind of common approach where we grab the start and end positioning from the self, but I suppose that'll maybe make itself more obvious in time. So what I'll do for the moment is this might actually just be usable like that. And at the very least, so first of all, there was an error in the actual source file that I must fix. But before that, method not found in, so that has to be defined in, okay, because I'm defining the trait right now. Yeah, so this is going to throw not a spanner in the works, but might not be as straightforward as I thought. So I'll put next int here, outside the trait, and but I probably won't have access to item. Okay, so I can still access it, but I have to fully qualify it. Yeah, I'll have to see about simplifying that shortly. So what was wrong there? Use fully qualified syntax. So if I do but it's saying that trait isn't defined. Let's see, usefully qualified. Syntax as trait. Oh, I have to have the actual trait name there, do I? So iterator maybe. Okay, there we go. Okay, so that's all I needed just to be able to access that type. So let's see. Oh, no, not that one. So let's see nViewTil. Oh yeah, so that was some example code that I'd written. There we go. So we're back to where we were. So yeah, maybe that's, again, it's not what I would love because this method is kind of capturing multiple responsibilities. So it's not quite fine grained. And in those kind of cases, I tend to wait until I can actually get nice functions before I start breaking them out. But realistically, for the readability of others, this kind of an approach probably does make a lot more sense and make things a lot more readable. So maybe I'll just go ahead and split this big function into these smaller functions, even though it's not the ideal, but it's at least better than what's there. So the next one is so next ident. So I'm going based off the kind of token that it returns. And let's just double check that. Yeah, that's all good. So I think that process seems to be all right. So I can probably apply it to the rest without too much difficulty. Quoted string literal. And in fact, this only ever returns some okay. So the option here is somewhat redundant, and yeah, that's why I was thinking that I wanted to change the return type, but I can do that in a moment. I don't have to do it right now. So in this case, there are different things that can be returned. Okay, but in the successful case, it'll only ever be a double kind of a double, what we'll call a double character token. There are multiple tokens defined by this. So, oops. And this one will be I'll double check. So this will be a quoted string literal or a keyword. And then the next one we go for is okay. Now this is part of a kind of a double, or I suppose a compound statement almost. So we're defining the match up here, and then kind of asserting it down here. So whether we want to do that at this point, this could actually be something that gets put into the same realm as next double character token, because none of these will match any symbols. Like, this is nice from a performance standpoint, I think, but because if it's a kind of a single character if it's a single character symbol, then it kind of gets matched right away. But we're not really going to be doing, because of the shortcutting nature of all of these are only going to do one character of look ahead at a time. So it's not really a performance issue to leave this to the end anyway. So maybe that's something to handle as part of this. So what we can do here maybe, so I'll copy that and put it here. I'll probably put it into a separate function again in a minute, in a moment. But let's see, is C used anywhere else actually? No, maybe that's not such a good idea. Let's see. So what are we doing here? We're matching, maybe there's something that could be put in its own function. So we'll say just match symbol. And that doesn't have to be a method for now. It probably would be nice to associate it with the method because it kind of, yeah, can I do a method without having it on self? Yeah, maybe I'll just leave it as a standalone function for the moment. And this would be a character, and it'll either, yeah, it'll return an optional token. Yeah, and that's nice and succinct. And let's see what that does now. And not found in this scope. So that's on line 270. Match C and next character. Oh, okay, yeah. So C is actually used in the double character checking as well. So we'll go past that. Okay, so that's working again now. Let's see. And in this case, oh, apologies. I'm going to have to switch over headphones, or earphones, or what have you. Just 1 minute. And there we go. I think that's recording again now. So let's see. We've moved that matching out, and we might as well match that as well. Let's see. So these actually match the same tokens, and it actually matches them more or less in the same way. What I'll do is I'll do it like this for now. I'll do a match. See you next chair. And that should now do the same thing as well. Oh, so I have to, that'll need to be none, and those will all need to be sums. I have to have a better mechanism than that. Oh, welcome back. Thank you. Thank you for joining. So basically just in the process of splitting all of these out using kind of class variables as a mechanism to avoid passing parameters all over the place at the moment, but it is something that I'd like to refactor if I can. Oh, I'm missing a type there, and 331. Yeah, missing a semicolon. So hopefully this section is now a lot clearer. So we have, depending on what we kind of detect is next, we say what's the function that handles that. And that's all working again now. And I just extracted this match double symbol token, which I believe is the same idea as what's up here. So I can actually use basically the same logic. Except the thing that gets returned in the case that nothing gets matched is different. So let's see. And on line 273, I'm missing something. Oh yeah, that should be a semicolon. Cool. So there's still a good amount of duplication between these sections. So let's see if we can whittle that down a bit. Now I can see that there's a bit of a difference in the ordering here. So up here, what we do is, this is an interesting one because here we know that it has to match two characters because no other tokens will match, and we know that if we don't match two characters, then that's an unexpected character. However, over here, we're still not sure at this point in time whether the next character makes sense for us. And so that's why we don't actually, we might potentially overwrite the end location after we match a second token. So that's the reason for the difference there. I wonder if there's some way we can kind of abstract this process and kind of capture both ideas in a single block of code. I suppose the tricky part is that is possible, and we could have this neat kind of even prefix tree representation of the different types of multi-character symbols that can occur and all these kind of things. But the big difficulty with that is it'd be probably a fair bit more work, but not much gained, and could even be less efficient than this more straightforward but maybe messier approach. Hi, Koo Bitty. Thanks very much, and welcome to the stream. Yeah, well, please feel free to check it out. I hope it's of some use. Yeah, it's definitely nice to see the Rust community growing. It's not, unfortunately, something I use kind of daily, but it's definitely captures most of my favorite new language ideas in a single language. So really happy to see it growing. So let's see here. So with all this done, maybe, so all of these do use C in the check, but not in the parameter, because they basically just start parsing, start building up characters from scratch almost. So what I might do, so that is, it's all right to leave that there. But what I might do with this stuff, so this can be removed anyway, that's old code. And might actually turn off numbers just for the moment, just to get a bit of screen real estate back. But please let me know if you'd like them turned back on. I don't have a great preference either way, but just a little distracting at the moment. Yeah, and I think Rust kind of enforces a lot of really nice ideas about programming, especially via the borrow checker, and the idea of, I think, knowing about lifetimes. I really like the idea that lifetimes are explicit in Rust, but then once you know about lifetimes, it's a lot easier to apply it in other contexts, and it kind of lends itself to good practices like dependency injection and all these kind of things, which I think is generally a good thing. So next, so maybe next symbol token, and what we'll do first. So this can be somewhat combined with this one. So we're kind of doing the same thing. We're checking, does the next symbol or does the next character match a symbol? And then we're seeing, does it match? We're kind of splitting up the symbols into two camps here. We're saying, is this a symbol on its own? And then we're saying, okay, if it is a symbol on its own, then is it also part of a bigger symbol made up of more, or is it part of a token made up of more than one symbol? And then this is kind of the third case, which is, okay, the first symbol isn't a standalone symbol, but when paired with the second one, it is. So, an example of this is, let's see, pipe maybe. No, maybe dot, colon. Actually, I'm not sure if any of these, if the first bits of equals plus. Ah, yes. Oh, wait, sorry. C equals is thanks for the comment, knowing Malif. But yeah, equals is a standalone symbol as well. So I wonder, is this actually still a valid kind of check? If it makes sense if there is one of these areas where one of the symbols in here in this column doesn't match any of the symbols in this column, but I'm actually not seeing any obvious ones here. So there's plus, minus, pipe. Pipe is probably the only one actually, and that's only because I haven't added support for the pipe operator yet. So that is one, but it might not always be. But it's probably good to have coverage for the two conditions anyway. So now that I've at least identified that kind of relationship between the different sections, I wonder, is there some way of combining them? So I'll just create a little scratch space for myself down here. And what we could say is, for example, if first char is in, I'll call it a single token. And then we have the condition if second char is in double token. This is kind of the logic that we have at the moment. So if So we do a similar check here. So we're saying if the second char is in a double token, then we return the double token. But then if there's no match for the first character, then we check is the second character in double token, and then we return double token. Otherwise, we return none. And that's an interesting kind of layout, because we do have this commonality now. But the difficulty is there is extra bookkeep. It would be fine if this was the case, because we could probably move this check to the start and basically do a check right off the bat to see if it's a double token. So let me think. Would that work? What? So set of Laravel in Vim, is it? What does that do? Set of and okay for I know. Unfortunately, this isn't the in fact, why was that giving an error? Or was it? Oh, there we go. So so let's see. Oh yeah, sorry. The extension is LRL, but it's the language itself is Laurel. I'll put it here in the chat. Isn't the test the other way around? Number one, check double. Two, check single. Yeah, I suppose that's the idea that I'm playing around with. So at the moment, the check. Whoops, there's so little. Oh, what have I done now? And there's so little screen space. Oh, oh dear. So let's get back into here. So where were we? Lexer. And I had my, let's see, parsing for a single char. So char token. Oh yeah, thanks for the comment, Lord MZT. So that's very likely to do with how I've set up the configuration of it. There were a couple of parameters that I'm not fully certain of, so I'd say I've actually configured it incorrectly rather than I'd say what you have written there is correct, but whatever way I set it up, it's probably set up to use the language extension rather than the name, the way I've set it up. But back to your question, Noon Malav. Sorry, I'm going to be butchering your username. But at the moment, the current setup is that we match a single token, and then if that is a match, then we attempt to look at the second token, and if that's a match, then we if the second token isn't a match, then we just return the first one. Otherwise, we do return the second one. And then if that whole clause isn't matched, then at the end of the function, we check for double character tokens, which goes in here. And it says if it is a double character token, then we match it. Otherwise, we say that it's an unexpected token. However, that's what I'm trying to reconcile here really is the fact that this this could ideally be merged with this section in some way or form, but it's not immediately obvious to me which. The difficulty, it seems like because in both cases we're matching the double symbol token, that we could put that logic first. The only difficulty is this logic shouldn't be performed in one of these cases. So if it's the case where it's a single symbol token and we're only going to be matching a single symbol, then we only want to perform next character once. Whereas if we attempt to match the double symbol token, then we perform the sync. Oh, we can actually avoid that by after we confirm the first character, then we do a peek on the next character. So actually, yeah, this is still a little bit of an idea, and others may have seen this ahead of me, but I think I've the makings of an idea here now. Oh yeah, that red line is my kind of 80 character column. I am old fashioned like that, in that I try to no, it's obviously not happening here, but just to keep allow for multiple columns on a screen, I try to keep to an 80 character limit, but as you can see, not paying mad attention to it during the development process. Rustfunked. I actually was using it for a while. It there are some there are some rules I'm not a fan of, but it's been a while since I've looked at it. Basically, I've a couple of custom. I suppose for me, Rust in general can be there can be quite a lot happening, especially on a single file with so many symbols. And so I've kind of a couple of my own conventions that I was following to basically add generous new line and vertical spacing to try and split them up, which I found that Rustfunked sometimes packed a little too much onto one line for my liking, but it's something that I do have to check out again, because it is generally preferable to doing it all by hand. Oh, is that so? Oh, I actually hadn't realized. For some reason, I had in my head that it's like go thumped and it's just out of the box. This is what it does. So, okay, I must take another look. So, because I actually hadn't even thought about the configurability of it. So, that would actually be very useful if some of those options could be turned off. Nice one. Thanks very much for the tip. So, coming back to here, what was the idea? So, first of all, we're more or less always going to want to capture this starting location anyway. So that's kind of a good place to start right off the bat. And we've already, in a sense, captured C by this point. Oh, thanks for the link. In fact, what I'll do now is I'm just going to click on that so it's open, and I'll be able to reference that after the stream. Thanks very much. So so we'll provisionally say this is where the next match ends, or the next token ends. And what we're going to do at this point is now we're going to do our initial token match. And I've actually lost my little note of what I was doing, but I think it was along the lines of if single, else, and then we did if double, return double, else return single, as in that's kind of the current logic. And then down here, if double, return double, else return none, because nothing is matched. So what I'm going to, so the refactoring is kind of along the lines of if single, then we continue, and then maybe it'll be something like else. Yeah, it'll probably just be removing a layer of indentation, really. So if single, else if double, yeah, it's, and we'll probably have to still do the same problem. It's really just reorganizing the else ifs, isn't it? Yeah, that's probably all that's going to be done, really. But let's see, there might be something else that can be done. So we're saying this is matched so far, and we're going to match that token. Or in fact, we haven't matched it yet because we're going to probably remove this from the final version. So we'll do a match here first. And if there is a match, then we're going to continue. Otherwise, it's basically going to be this logic then. So next double character token. And in fact, I'll call it next double symbol token. And so at this point, we've determined that there's at least one character in it. And then we're going to try and determine whether there's another character after that. We'll try and match it based on the next character. And in fact, all of this stuff can go into here. So at least we've removed it from this function and tidied up the function somewhat. Instead of calling next double symbol token, we'll call this next symbol token. And in fact, instead of match symbol token, we'll call that match single symbol token, to kind of serve as a complement to this match double symbol token. So we'll save that for now anyway, and run it, and that is compiling, which is somewhat worrying, but for the most part, it was really just moving things around, so probably not too surprising. Now, it would be nice if a bit more code could be shared by this next double symbol token and next symbol token, because they're doing somewhat similar things. Yeah, I'm not. So I'm not too happy with how this is distributed between, how this kind of functionality is distributed between these two functions. But at the same time, there is a point of diminishing returns, and I could end up actually making it, in an effort to make it simpler, I could actually end up making it more complicated. So what I might do is focus on some other refactorings for the time being, and maybe some more obvious refactorings, and maybe a more obvious approach to refactoring the next symbol token slash next double symbol token will present itself in time. What's there is fine for now. I suppose the big thing really was splitting this next function up into more meaningful parts and removing a lot of the shared code between those two symbol token matchers. So with that all said and done, are there any other obvious improvements I can make to a number of these? So a lot of these are starting with this start equals self index, followed by start location is equal to self location. One, I would say, somewhat obvious improvement in a lot of these actually is that I can remove the sum okay, the option part of a lot of these, because they and why is that okay as well? Oh, because it's an item, and spanned is a result. I can put that into its own type, I'd say. So let's see, spanned. So that'll be spanned result. And in fact, I don't really necessarily need a type for that. I could potentially refactor that in a moment as well. But for the moment, let's do this. And remove the result from here. In fact, I don't need error there either. It needs to go there instead. Let's see. And I'll actually leave that to where it was. Yeah, and that seems to be holding up all right. So what I can probably do here is replace that with spanned. Do I still need the, I don't, I can actually simplify this to, and is there a need for even having spanned anywhere actually? Or can I would say I can just define, can probably just define it without the generic parameters. I'm not sure if I lose much by doing it, but don't think I do for the most part at the moment. Probably do in some theoretical sense, but not so much practical. And so I can probably do this now, and let's see if all the types are lining up correctly. Nice. Yeah, so that's a few hoops to jump through there, but that seems to have simplified things considerably, and in fact I can just refactor that as well. Yeah, so there we go. Not sure spanned really needs to be public, but I think it's fine the way it is for now. And we'll go spanned here. Like, does spanned make the most sense? Would I call it region instead? The idea being that it's a token surrounded by the start and end positioning. I think it's all right for the moment. Okay, at this point I do probably want to return an option though. And so that'll be some one of those. And all of these will want to return some okay. Except for this last one, which will have to be based on so this would want to be a combination of a result. Well, no, actually that doesn't need to be a result either. So this was under the assumption that an EOF at this point of time in time was unexpected, but that was kind of a workaround for a specific case in during debugging. Whereas what we really want to do here is say else if, well, that would be kind of an if let maybe. We'll put it in here instead. So what we're going to say is if there is some token defined by this, then we return it. However, if there isn't, then we return some error. And this is where we would return the unexpected character. So we would have the duplication here, but yeah, and I think that works then. So then in this case, we instead return none. And also this can be refactored as well to update all of these to make one big expression. So there's that, and then we can refactor these guys. So if so we've matched the first character. I actually don't need a return statement at the end of a lot of these as well, I'd say. So let's see, going back here, we attempt to match a single symbol token. If that's all right, we attempt to match another, and if that fails, then can probably no, I'll probably leave that the way it is, although there is an overlap that I could potentially abstract as well. No, I think that's the safest to leave the way it is. And what I'll do instead, so that should be sum as well. Remove those return statements. Cool. So that all seems to be lining up again all right. And I've gotten rid of this debugging item as well and removed that extra character. So a lot of the no commit kind of comments that I had intended to do are actually done now, and that kind of monstrous next function has been kind of whittled down piece by piece. So with that all done, that's actually a big chunk of what I had hoped to do today and in general. Oh, I'll have to update that copyright notice. Hasn't been committed yet, so that's copyright 2022. Again, just copyright open source wise, so that people can actually modify this. And so, what are the other files that got changed? Oh, main. And then the LALRPOP. There we go. And so, oh no, that's gonna cause a big delay while LALRPOP regenerates the parser. But let me just double check the my to-do list. So yeah, that got done. Yeah, removed the debug errors. Abstract duplication of double character token matching got done. Use token with references. Yeah, that hasn't been done yet. And the location doesn't capture line number. Oh wait, no. I think it does capture line numbers actually. So location consists of a line column pair. So that's actually completed. Names of operator bindings. Not quite sure what I intended with that. I might have to rewatch the last stream. Arithmetic binding operators, so that's the likes of plus, equals, and things. I think I have all of those. And those are all sorted, aren't they? Sorted by however the sort program works. and then LALRPOP generics. Yeah, I think there was limited application of that as well. So the main thing that I probably want to add in is the use of tokens with references. That could be nice. Um, but isn't essential. It's more a performance boost really more than anything. I think the work is more or less functional without it. So yeah, I think it's actually in a good position to, again, because it's in a state where it's easy for this to have a lot of knock-on effects without me even realizing. I still have to figure out whether to merge it into to the branch it came from, or to keep on this. Yeah, I probably will, and then have a new branch which is more solid, which has more comprehensive testing. But yeah, we'll I'll commit what I have anyway. Um, so we'll go git add p. Yeah, that was the that was what was causing my original comment issues, that I wasn't adding new lines back into my kind of red file. And I'll just do one last pass through the Lexer file just to make sure that um, everything is the way it should. Seems seems a bit unnecessary to have the Lex error be an enum, since there's only one case, and it kind of makes sense that the only Lex error that is possible is an unexpected character, because if we think about it, the only other real case, because all it's doing really is it's saying take a string, read the next couple of characters, and see what the next token amongst them is. And the only thing that we can really fail on is if the next character is something that, if the very next character is something that we don't support, because any other condition really, if basically if we start a match, then we're able to go up until a point of an unknown character, at which point that's an error for the next invocation of that function. So the only, and if there is an issue with an EOF, then it's the same thing. If the EOF happens a couple of characters ahead, then we're still going to be able to read characters up until that point. So the EOF issue is going to be just a case of returning none in a later call. So the only real, in my opinion, possible lexical error is an unexpected character. So maybe it makes more sense to define this as a struct, and though I say that, I do like the convention of errors being enums. Even though there's only one case in this, and it would probably make the matching simpler to have it be a kind of a unit type. I think maybe it's more important to follow what seems like a good convention in my opinion. So maybe I'll leave it the way it is there. Yeah, there's actually a lot of moving parts in this, which probably aren't needed, and it would be nice to minimize that at some point. And for example, we have start there. Oh yeah, so we capture indexes so that we can read into the original buffer, but then we capture locations for our error messages and spans. Um, Maybe instead of span, I'll just call it span. Any other bits of cleanup? I mean, there's a lot to clean up, but any other kind of glaringly obvious ones, I wonder. So that can be changed to that. And same for the others. Yeah, I think that's about it. And add custom. In fact, yeah, I didn't commit a kind of a partial implementation earlier. So add custom, I suppose just lecture. And that's it. Do a git push, and that is the work of, I suppose, 3 streams at this stage. Which is nice to finally see the end of. Again, it's probably something that I should exercise caution before continuing on, but again, it's the difference between kind of, I suppose, having interesting content for the stream versus, yeah, having having something that is going to be fun for other people to hack on in terms of the public repository. So I'll have to balance the two of those. But yeah, that more or less brings us up to the end of today's stream. Thanks very much to everyone who joined in and commented and watched and um, kind of had questions about the project and everything. So yeah, thanks very much again, and I hope to see people next week again. Take care and have a good weekend.